Here in this video, I'm going to talk about counting techniques. Counting techniques, they are important here in probability because the first time you're learning probability of your or if this is your first course in probability, you will realize later that computing probabilities for what we're going to define as events is essentially reduced to counting or to count. That's why having or knowing some counting techniques is going to be important, especially again, the first time you are studying probability. Counting techniques. The first counting technique we're going to see here is the product rule. Suppose a set consists of ordered collections of k elements and that there are n1 possible choices for the first element. N2 for the second one, N3 for the third one, and so on, up to nk for the kth element. So we have a collection of k elements. Collection of k elements, and there are n1 possible choices for the first element, n2 for the second one, n3 for the third one, n4 for the fourth one, and so on up to nk for the kth element. Then there are n1 times n2 times n3 times and so on up to times nk. K tuples or sequences of k elements. So the first counting technique is called the product rule. If you have, in general, it said that you have several ways to do one task, other several ways to do other tasks, and so on. In how many, if you're going to realize, if you're going to do all the tasks in a sequence, then in how many ways you can do all of those possible tasks? Well, it's simple. You will have to multiply the numbers, and that's the meaning for this one here. Multiply all the possibilities. For example, examples. This is one example from your homework in web work. It says at the restaurant there are 5 kinds of pasta and 2 types of sauce. How many different ways can a customer order one kind of pasta and one type of sauce? So what do we have to do? In this case, it's very simple. We have five possibilities from pasta and two possibilities on the other one. Since we're trying to see, pasta and sauce, then we have to do a multiplication in this case because we're trying to form a sequence. So in this case, it's going to be only 10. Yeah, here we are not choosing like one either pasta or sauce. No, we are choosing the two at the same time. That's why we have to multiply. If the question were in how many ways you can choose one or the other one, then in that case, you would have to add, not to multiply. But this is not the case. Here is saying pasta and salt. Pasta and salty. So we have this. I'm sorry, this work. So that's why we have to multiply. Next example. It says a man has 5 ties, 6 shirts, and 5 different pairs of trousers. So, question: how many different ways does he have to dress himself? So we have here 5 ties, 6 shirts, and 5 different pairs of trousers. How many different ways does he have to dress himself? Well, in this case, what do we have to do? Again, we are not asking how many possibilities from each of them. We are not picking only one. This person is not picking only one, but is going to choose all of them as a sequence. First, tie, shirt, and trouser. In how many ways he can do that? Well, in this case, it's going to be only a multiplication. 5 times 6 times 5. And this is equal to 150. You see? This is the multiplication principle. Again, the main point with this technique is that when you are, I think that's something that can be helpful when you are trying to apply this counting technique. We're going to see other ones, but I think some keyword that might be helpful is this one, sequences. If you think that for your answer you are forming sequences, maybe because we have other techniques, but maybe you will have to use this technique. This technique, product rule, multiplication, because here we have sequences of pasta and saucy, and here we have sequences of ties, shirts, and trousers. Other technique, permutations. To motivate this technique, Let's start with one example. How many arrays of the letters A, B, C are there? Let's say that we have the letters A, B, C, and we want to order them in certain way. Like, I mean, create arrays of three with the same three letter. The same size, three letters, by using the three letters. So how can we do that? It's not very complicated if you try to do this by writing down the possibilities. For example, one possible way is A, B, and C. Other way, keep the A in the first position and switch the order for the B and C, C, B. Other way, we can put first B, then A and C. Other way, put first B and then C and A. Other way, put first C and then A and B. Other way, first C and then B and A. You see? If you count this, we're going to have 6 arrays. Well, these arrays of these three letters, they have a name. They are called permutations. 6 permutations. Now the definition is a permutation is an ordered array of n items. So if you have n items and you want to compute the number of permutations for those n items, you can compute it with the next formula. The number of permutations of n items is given by this thing here. You have to read this as n factorial. N factorial, and this means n times n minus 1 times n minus 2, and so on, up to 3 times 2 times 1. In the previous example, this one, notice we have 1, 2, 3 items. The letters are the items in this case. So there are n factorial equal to, in this case, 3, because we have 3 letters. 3 factorial, and it's equal to 3 times 2 times 1. And this is equal to what? 6. 6 permutations. You see? It is, of course, it is the same that we counted. Many times it's not going to be very important what the permutations are, but how many. That's going to be more important. If you have a scientific calculator, you can compute this directly by finding a key that is similar to this. This is the key to compute permutations. without doing without multiplying 3 times 2 times 1 or whatever. Only usually you only have to press the number of items and then this key, and you will have the answer. Now, other technique, permutations of n items taken r at a time. What about, remember the previous example? We have 3 letters and we try to compute the permutations. Well, we computed the permutations actually. But now let's modify this little example, a little. What about how many permutations are there of the letters A, B, C if we take only 2 letters at a time? Yeah, in this case, we're not choosing only, we're not taking into account the 3 letters to create the arrays of the permutations, but would this be if we choose only 2 letters? That's the point. So notice, again, I think we can count this without so much complication. So this is going to be, one possibility is AB, other possibility is BA, other possibility is AC, other one is CA, other one is BA. No, I'm sorry. BC and CB. Permutations of n items, in this case the letters A, B, C, but taken 2 at a time. How many are there? 6. Yeah, I know. It's you maybe you see that, oh, it's the same as before, right? Yeah, but it is only a coincidence. I mean, it's not the same concept. That's my point. So in this case, we have 6 permutations. And the same as before, it's not going to be very important what the permutations are, but how many. So the number of permutations of n items taken r at a time is given by this is the symbol we have. Permutations of n items taken r at a time. And what is the formula? The formula is going to be n factorial divided by n minus r factorial. Here, be careful. If you're trying to do this by hand by using this formula, you will have to realize that you need to subtract n minus r first and then apply the factorial. Remember this symbol in this case, in this context, means factorial, the one we have here. So we have to compute a quotient of 2 factorials to compute the number of permutations of an item taken r at a time. In our example, we have n equal to 3 and r equal to 2. And yes, I'm talking about this example. We have 3 letters and we're taking 2 at a time. You see that? 2. So n is 3 and r is equal to 2. Then permutations 3 choose 2 is equal to 3 factorial divided by 3 minus 2 factorial. And this is equal to 3 factorial divided by 1 factorial. Again, be sure that you do first the subtraction, 3 minus 2 and then 1. And this is equal to 3 factorial divided by, oh, I'm sorry. This is equal to 3 factorial divided by 1 because 1 factorial is 1. So what is left? Only 3 factorial, but we saw before this is equal to 6. And this matches with this, right? Because we have 6 permutations. Now, combinations. How many arrays the same example of the letters A, B, C taken 2 at a time. But if we do not care about the order. So we're going to repeat the process, but we have 3 letters. We're going to choose 2, but in this case, the order doesn't matter. What do I mean with that? Notice, in the previous example of permutations of an item taken at a time, we have these 2 letters and we were choosing 2. But we counted as 2 different arrays, A, B, and BA. That, in certain cases, might be okay. But what about if for me the same A, B, or BA? The only point is that the array that I have is the array with the elements A and B. That's all. If A and B or BA, the order doesn't matter for me. Actually, I have only 1 array, not 2. Again, that's going to depend on the context of the problem. But we have AB, BA. But this is only 1 array. If I don't care about the order, because AB and BA are the same for me, I want to know only what is the array with the letters AB, and that it's only 1. So I can choose a representative of the array with AB or BA. It could be AB or BA. I'm going to choose AB. So this is the array AB with the elements AB. And the same for the previous one, BC, CB. If I don't care about the order, BC or CB is the same for me in the array with the elements B and C. So I write only, for example, BC, a representative of BC or CB, and AC and CA Again, this is only one array with the elements A and C. I don't care about the order, so I choose a representative that can be AC. You see? So how many do I have? 3. When we don't care about the order, we call the permutations combinations. We don't care about the order. And of course, we have a formula for this. The number of permutations, combinations of n items taken R at a time is given by combinations n choose R. This is combinations of n items taken R at a time. Or other notation for this is this one. It's the same. The meaning is exactly the same. And the formula is n factorial divided by R factorial times n minus R factorial. In our previous example, we have n equal to 3 and R equal to 2. So combinations 3 choose 2 is equal to 3 factorial divided by 2 factorial times 3 minus 2 factorial. And this is equal to 6 divided by 2 times 1 times 1 factorial. And this is equal to 6 divided by 2 times 1, 6 divided by 2, and this is equal to 3, you see? And of course, this is the same as the result we got here. 3 combinations, you see? 3. All right. In your calculators, of course, if you want to do this by hand, no problem, but you can do it in your calculator. For permutations, look for the key NPR. In most of the calculators, this is the key NPR, or for combinations, NCR in your calculator. Something to point out about combinations. Note, combinations can be thought as the number of subsets with R elements from a set with n elements. How many subsets are there with R elements from a set with n elements? That is given by the number of combinations. For example, given the set A, B, C, and D, how many subsets with one element are there from A? So we can count in this case the subsets. Notice it's not very complicated because it's going to be one subset from this set with one element is each subset with the corresponding element. For example, one is A, other one is B, other one is C, and other one is D. Here I have 1, 2, 3, 4 subsets. They are subsets of the set, and each has one element. But of course, what about if I want to if I don't want to specify what the subsets are? Instead of that, I want to know how many. Well, in this case, I can use combinations. There are combinations for, in this case, because we have 4 elements in the total set, and we want to know how many subsets with size 1 or with one element. So combination 4 choose 1 is 4 factorial divided by 1 factorial times 4 minus 3 minus 1 factorial. And this is equal to 4 factorial divided by 3 factorial. And this is 4 times 3 times 2 times 1 divided by 3 times 2 times 1. And this is equal to, notice how I can cancel this, and this. So what is left only? Only 4. And of course, this is the answer, right? 1, 2, 3, 4. 4. Finally, let's see one example from WebWork. It says, this is one example from WebWork. How many ways are there to select 8 countries in the United Nations to serve on a council if 3 is selected from a block of 51? Maybe it can 3 from 51. 3 are selected from a block of 68, and 2 from the remaining 70 countries. One hint. Notice, for example, let's focus only on the for the council of 3. 3 is selected from a block of 51. In how many ways we can do that? We have 51 items, yeah, items. I can say that here in this case we're talking about, the items are the nations, 51, and we want to choose only 3. In how many ways we can do that? When you're choosing some from a total, a given amount, very likely, or well, maybe I could say that almost for sure in this class, is going to be permutations or combinations. But how do we know whether it is permutations or combinations? Well, if the order doesn't matter, if it doesn't specify anything else as to how the elements must be selected, then it is very likely you will have to use combinations. So in this case, the answer is I'm going to express it as combinations. For the first one is combination 51 choose 3. And then I have to do the same for the other ones. 3 out of 68. And finally, you see, 2 out of 70. Combination 70 choose 2. Now, notice, the question is how many are there to select 8 countries? Here we have 3 countries, here 3 and here 2. Together, I'm forming a sequence of 8 countries. Once I have the options here and this, I will have the 8 countries. So what do I need to do with these numbers? You're right. Apply the multiplication principle or the product principle, or how did I call that? The product rule or multiplication principle. So I have to apply this. And if you do this, let me see if I have here a scientific calculator. I have to do 51.3. Here I have a function. Notice it's in the bottom. Combinations. 51.3. 51, 3 times. By the way, this is the Desmos Scientific calculator. Desmos Scientific. You have your tablet or iPad or your iPhone or your cell phone. I think it's a very good application. It's for free. The other one is 68.3 times combination 68.3 times combination 72. And you can verify, notice here to the right, almost in the edge of the screen, you will see that the number is 2.5204527 times 10 raised to the 12. And that answer, you can verify, is the same answer we have here. You see? All right. So this multiplication, this one, is this answer. Okay? All right, that's all. See you in the next video.